This recording contains essential information regarding the oscillating steam engine model. You will learn how the device was constructed, the principles that allow it to operate, and the materials and methods used in its assembly. Physical description. The device is constructed on a 2 mm thick aluminum base plate, measuring 3 by 12 centimeters. Several holes were drilled into this frame to hold the main components. One opening carries the central shaft, which connects the flywheel to the crank arm. A bearing was installed on this shaft to reduce friction and allow smoother rotation. The crank arm is an aluminum disc with a radius of 13 mm. 10 mm away from its center, a pin was mounted to connect the piston rod. The flywheel was made from the aluminum shell of a candle. After the wax was removed, washers were attached to its sides to balance the wheel and give it enough weight to carry the piston through each cycle. The main cylinder is a section of aluminum tubing, 15 mm long, 10 mm in diameter, with walls 1 mm thick. Inside moves the piston, its head also 10 mm across. The cylinder is fixed to a second aluminum plate, 15 by 15 mm. This plate is mounted to the base on a pivot, which allows the entire cylinder to swing slightly during operation. Unlike most common designs, the pivot is not placed at the center of the cylinder, but higher on the mounting plate. A small string along this pivot shaft presses the cylinder tightly against the base plate, ensuring the intake and exhaust ports remain sealed as they align during motion. 2 ports are drilled into the base plate. One serves as the intake for compressed air, the other as the exhaust. For presentation, the entire assembly is mounted onto a wooden base. Operating principle. The oscillating steam engine works by using the cylinder itself as the valve. As the piston moves back and forth, the cylinder pivots on its mounting shaft. In one position, the intake port aligns with the opening in the cylinder and compressed air flows inside, pushing the piston forward. When the piston reaches the other side, the cylinder swings and the exhaust port aligns, allowing the used air to leave. This continuous switching between intake and exhaust drives the crank arm and flywheel in steady rotation. Construction difficulties. The engine was assembled under basic workshop conditions, with no lathe, drill press, or proper air compressor. Aluminum scrap, hand tools, and the spray gun compressor were all that was available. At first, the small size of the model allowed full-scale drawings to be made, mapping every position of the cylinder and its ports. But a misaligned pivot hole shifted the cylinder by 1 millimeter or 2, making the blend useless. The exhaust port worked, but the intake port never aligned. To fix this, the hole was enlarged and reshaped with a small pin and hot glue. This allowed the engine to run, but also created a weakness that prevents it from ever operating on real steam. Other issues soon followed. The first flywheel, a candle core, lacked inertia and was replaced by a hollowed candle shell with steel washers for balance. Lubrication was also problematic. Cold winter temperatures in the unheated shed made the motor oil too thick, increasing friction. Only when both the oil and the shed were warmer did the piston move freely and the engine reach proper speed. Despite all the difficulties during construction, the engine now operates smoothly. It stands as a small but striking demonstration of how important and revolutionary steam power was for the development of human civilization. I hope you enjoyed this presentation, and thank you for watching.